All right, this is section 7.4, and today we're going to talk about complex numbers. So, what is the square root of a negative number? For instance, if I said, what is the square root of -1? Well, some of you might say, well, it's -1. But it can't be because -1 times -1 would be a +1. So it can't be -1. So you might say, well, it's 1. But 1 times 1 is a +1. So it can't be 1 and it can't be -1. So if you remember back from Algebra 1, when you got the square root of a negative number, your solution would have been no real solution. But now we can take the square root of a negative number because now we're going to talk about complex or imaginary numbers. So I squared is -1, or more importantly, I is equal to the square root of -1. So let's see how we're going to use that to help us simplify negative radicals. So if I have the square root of -9, I'm going to break that down to two radicals, just like I always do. But I'm going to break it down to the square root of -1 times the square root of 9. I'm going to simplify each of those. The square root of -1 we have now learned is equal to I. So I'm going to simplify the square root of -1 to I. And I'm going to simplify the square root of 9 to 3. There's a rule in math that you always have to have the real part first and then the imaginary part. So I'm going to write this as 3I. So the square root of -9 equals 3I. Let's try a couple more. So you're always going to start by breaking out the square root of -1, and then you're going to break down the number 40, for instance, just like you did in the previous lectures. So I'm going to break -40 down to the square root of -1, the square root of 4, because that's a perfect square, and then the square root of 10. I'm going to simplify this. So the square root of -1 is I. The square root of 4 is 2. And the square root of 10 is simplified simply as the square root of 10. I'm just going to rearrange this and say 2I square root of 10. You tend to put the I in front of the square root just so there's no mistake that the I is underneath the radical. All right, square root of -32. I'm going to break that down to the square root of -1, square root of 16 because it's a perfect square, and the square root of 2. You can see if I multiply those back together again, I still have -32. So I haven't changed the problem, I've just rewritten it. The square root of -1 is I. The square root of 16 is 4. And the square root of 2 is simply the square root of 2. I'm just going to rearrange this for 4I square root of 2. All right, let's try a couple more. I'm going to break down the square root of 36 to the square root of 1 times the square root of 36. And that -3 out front is just going to continue down. When I simplify this, I'm just going to carry down the -3. The square root of -1 is I. And the square root of 36 is 6. But now I have two numbers that I could multiply together because these are all multiplied. This is -3 times I times 6. So -3 times 6 is -18. So my final answer is -18I. I can break -18 down into -1 square root of 9 square root of 2. I'm going to bring down the 5. Square root of -1 is I. Square root of 9 is 3. And the square root of 2 is simply the square root of 2. I can multiply the two numbers out front together. 5 times 3 is 15. So I have 15I square root of 2. Why don't you put the video on pause and see if you can do this one on your own. All right, let's see how you did. So I'm going to break down the square root of 12 into the square root of 1, square root of 4, square root of 3. I'm going to bring down the 2. The square root of -1 is I. Square root of 4 is 2. Square root of 3 is just the square root of 3. I can multiply those two 2's together, and I'll have 4I times the square root of 3. Now I can also add and subtract complex numbers. All right, you still want to keep it in the real plus the imaginary part, so your answer should still be in the a plus bi form. But when you are adding and subtracting, you are going to combine like terms. So if we take a look at this example, I have 3 plus 2i plus 6 minus 9i. So my 3 and my 6, those are like terms, and notice that the sign always goes with the number, the sign in front. So 3 plus 6 is 9. And then I have my plus 2i and my minus 9i, and when I combine those, I get negative 7i. Remember that you always want to have it real plus the imaginary part, so I want to keep this as 9 minus 7i. I do not want to write it as negative 7i plus 9. Okay, let's try another one. I'm going to combine my like terms, so 5 minus 5 is 0. Remember, 0 is a perfectly legitimate number. My other like terms are 2i and negative 4i, so that'll be negative 2i. And I can leave it as 0 minus 2i, or I can just simplify it down to negative 2i. Either way is fine. And you are still in the real plus the imaginary part either way. All right, on this one here, if you remember, there is really a 1 in front of this parentheses. So the first thing you're going to have to do is distribute that negative or negative 1. So I'll get 12 minus 5i minus 5 minus 2i. Now I can combine my like terms. 12 minus 5 is 7. Negative 5i minus 2i is negative 7i. And I'm in the correct form, the real minus the imaginary part, so this would be done. All right. Once again, on this one, you want to distribute first. So 4 times 3 is 12. 4 times negative 4i is negative 16i. Now that I've distributed, I can combine my like terms. 12 plus 8 will give me 20. Negative 16i plus 6i will give me a negative 10i. And I'm in the real plus imaginary part, so I'm all done. All right, if you have any questions, please let me know.